For this module, we'll be working with a knapsack problem, and you should be familiar with it before continuing. You'll find one attached to this video. Given that we know what a knapsack problem is, we'll need to specify a number of items that we are going to pack. We want the model we are creating to be as general as possible, and that means that we do not want to write the number of items that we're packing more than one place. In this case, what we're going to do is that we're going to create a parameter. This parameter we're going to call n, and we are setting it initially equal to 4. This means that we're going to have 4 items in our model. And for each of these items, we're going to have to specify some properties. To facilitate this, we're going to use a concept called ranges. A range is created by writing like this. First the keyword range, then the name n, and then we need to initialize it. And we start with 1, and we're going to end up with n. So capital N is now the range from 1 till lowercase n. For the model, we're also going to need a capacity, and I'm just going to initialize that to 9, like this. Now we need to specify 2 things regarding each of the items that we can pack. Each are going to be assigned a price and a weight. To accomplish this, we are going to use the range we just created. The type of each of the prices is int. We call them p, but we are not just going to need one of them, we are going to need an entire array. And the size of that array is going to be n. This you're going to write like so. So p is now an array of size 4 going from 1 to 4. The first element is 2, the second is 8, the third is 2, and the fourth is 6. Likewise, for weight, we're going to need some integers. We're going to name them w, and again, we're going to have 1 for each possible value in the range capital N. And these values are going to be 6 for the first weight, 3 for the second, 1 for the third, and 4 for the fourth. Lastly, we'll have to define our decision variables. So as you remember, we used the keyword dir. In this case, we want it to be booleans like this, and we can call them x. But we're not just going to need 1. We're going to need 1 for each item, and the interpretation will be if that value is 1 or true, we are going to take that item, or if it's 0, we are not. We define it just like we did for p and w, like this. Now we are going to need the objective function. Recall that in an knapsack problem, we want to maximize the profit. So how do we calculate the profit? Well, the profit is something with p, and we need to multiply it with x to only count those that we're actually taking. So we could say p1, x1, plus p2 times x2, and so on and so forth for all the 4 values. As you can see, what we're doing is quite systematic, and you might expect that there's a smarter way of doing it, and that's actually correct. What we can do is instead use the keyword sum. So we delete what we just had, and instead we write sum, and we need to sum over something. So we're going to sum over n, but we need a variable, so we say sum I in n. And what we want to do is we want to take pi, the ith price, times the decision variable that tells us whether that price was actually obtained. So we do like this. The advantage of this is if at a later point we're going to have 10 items or 100 items, we're not going to have to change the objective function. Also, it's much less prone to errors. When using sums, there are, however, a few things that you should be aware of. When choosing the variable name I took care not to reuse a variable name I used earlier. If you try to do it, OPL Studio will warn you, so that's not a big issue. If, however, I did something like this, after the sum plus added something, you'll see that OPL Studio is warning me. And if you mouse over this warning, you'll see that this I is not defined here. I does not exist. That's because the sum is only working on the first part of that equation. So be very careful when you do this. If you wanted it to hold for the whole equation, you could use parentheses like that. Sometimes it's worth having a few extra parentheses just to make it very explicit what you're summing over. For now, I will remove the weights as they are not actually part of the objective function that we are trying to model. So now for the constraints. Recall again that to impose constraints, we're going to need the subject to. So what do we need to do there? As you can see in the comment, we want to enforce that we are not carrying more weight than we have capacity for. This is again something that we can express using the concept of a sum. I'm going to reuse the I because the I used previously is only scoped to the maximize in the objective function, so I can reuse it. If you're in doubt, you can just try, you'll get warned if you can't. So again, I'll say sum I and n. And what I'm trying to sum here are the weights, W's, but of course we're only going to sum the weights that we are actually, of the items that we are actually packing. And this sum, of course, needs to be less than the capacity, which was the cap parameter, less than or equal to the cap parameter. This concludes the knapsack model. It's a very compact formulation and easy to read, hopefully. There are, however, some concepts that you might need later. Sometimes, if you, for instance, sum in the objective function, you're not necessarily going to want to sum all of the items, and you can limit what you sum over by using this colon, and then you can write an expression. For instance, if you want to only sum the items whose weights are greater than 1, you can express it like this. This would ignore any items with a weight that is 1 or less. If you want to combine multiple expressions here, you can say this should hold true and, only 2 ands, something else should hold true. Alternatively, you can say this should hold true or something else should be true. These can be combined as many times as you like, but be very careful when doing so about expressing what you actually want using parentheses. So, for instance, if you have 3 expressions, A, B, and C, and you want A and B or C, what does that mean? This expression where you have B or C and A is radically different from A and B or C. So be careful when you do this and use parentheses liberally to express what you're actually trying to do. This concludes the knapsack lesson, but there's more we can use ranges for. For that, see the next module.